So today we are going to talk about proofs with parallel lines. Sometimes we're going to prove that angles are congruent to each other, or that they're supplementary using some of our relationships from yesterday. And also we're going to use the converse theorems and postulates that we learned yesterday to show that lines are parallel. So you might want that handout from yesterday, or if you haven't memorized, I'm going to quickly write them on the board, those relationships. Okay, we had 4 types of angle pair relationships yesterday. What was the first one we talked about? Y'all remember? Start with the corresponding angles.
Alternate interior.
All right, angles. Alternate interior. Yeah, alternate interior angles. Exterior angles. Alternate exterior angles. Exterior. Did I spell that right? And then consecutive interior. Interior. And then we learned the theorem for these angles, and the theorem, or actually it was a postulate for corresponding angles. If 2 parallel lines are cut by a transversal, which makes that makes corresponding angles what? Congruent, right? Corresponding angles are congruent. And another theorem said if 2 parallel lines are cut by a transversal, then alternate interior angles are what? Congruent. And another theorem said if 2 parallel lines are cut by a transversal, then alternate exterior angles are congruent. And another theorem said if 2 parallel lines are cut by a transversal, then all consecutive interior angles are what? Supplementary, which means what? Added together, they equal 180 degrees. Right? Which also means they form a linear pair. Right? All right. And then we learned at the end the converse theorem. Remember, a converse swaps through hypotheses and conclusions. Okay? So the converse theorem basically stated for corresponding angles, if 2 lines are cut by a transversal such that corresponding angles are congruent, then the lines are parallel. Right? So for all of the converse theorem, you're just told 2 lines, but if these angles are congruent or supplementary, then the lines are parallel. Right? So we're going to use a converse theorem, I'll stutter, to prove that lines are parallel. And that's why it's highlighted on the screen. All right, so this is our first proof. Now, it didn't really do a given and a prove like we've been seeing, right? But this right here, it says prove P is parallel to Q. There's my clue that I need to do a proof. All right? So on your paper, hopefully you've drawn the picture. Let me get some red pen. You need to have your statements. And your reasons. So make you a T-chart for statements and reasons. Mine's a little crooked. I ain't gonna lie. That's a little better. All right. So, what do you think is my given? R is parallel to S is part of it. All right. I'm gonna do all my givens together. R is parallel to S, and angle 1 is congruent to angle 3, and both of those are given. Y'all okay with that? Okay, well, I'm going to mark that those angles are congruent as well. So I have marked on my picture R and S are parallel. That's what those red triangle things mean. Those are parallel lines. So I'm trying to get to proving that P and Q are parallel to each other, because I have four lines here, don't I? I know that R and S are parallel. They told me that. I'm trying to prove that P and Q are also parallel. So I know that eventually I'm going to have to use a converse theorem, because that's how you prove lines are parallel. Correct? So I'm going to have to finish it with a converse theorem. So what I need to do is find a pair of angles that are congruent that would make a converse theorem to say that P and Q are parallel. All right? So, angle 1 is congruent to angle 3. All right? Are 1 and 2 congruent? Yes. Because if I ignore line P, what's 1 and 2's relationship? Corresponding angles. So I can say that. Angle 1 is congruent to angle 2. And the reason is because they are corresponding angles. That's a postulate. That one's a postulate. The other ones are theorems. Okay. Well, look what I got here. Angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2. So what can I say now?
Angle 2 is congruent to angle 3.
Angle 2 is congruent to angle 3 because of what? Transitive property. Very good. Now, the 2 and 3 have a relationship? Yeah, they're alternate interior angles of P and Q, aren't they? With R being the transversal. Y'all see that? So, now that would prove that P and Q are parallel to each other because of the what? Alternate interior angles converse theorem. Yeah, now I got it. P is parallel to Q because of the alternate interior angles, and you got to say converse. Okay, so since I have stated that 2 and 3 are congruent to each other, and those would be alternate interior angles to these two lines. Ignore line S, just look at R, right? So those would be alternate interior angles between line P and line Q being parallel. So since they're congruent to each other, then I can say P and Q are parallel because of the alternate interior angles converse theorem. That's it. I did it. We did it. We did it. How are we going to get good at these?
I guess.
Practice, and this is example 1. You think we're going to do a lot more practice than this?
No.
Heck yes, we are. Heck yes, we are. All right, here's another one. That's a 1 right there. This one I'm sure is similar because we're proving lines are parallel again. So we're again going to use a converse theorem to prove that the lines are parallel. So y'all go ahead and set that up. You can go ahead and do your statements and reasons table if you want to. And you probably could go ahead and tell me the given. That's a 1 with a little art mark showing that they're congruent because it told me that angle 1 and angle 3 are congruent. How many given things did they give me?
2.
2. What's one of the givens? A is parallel to B. And what else?
Angle 1 is congruent to angle 3.
Angle 1 is congruent to angle 3. So it's starting out like the last one did, except for our angles are in different positions, right? Okay, so, what's my first reason? Given, always, always, always. So I'm trying to prove that C and D are parallel. So A and B are parallel, and I've marked those with those extra angles. I'm trying to prove that C and D are parallel. Okay, and I'm going to obviously use a converse theorem at the end to say that, right? Anytime you're proving lines are parallel, you're going to have to use one of the converse theorems. All right. So 1 and 3 don't have a relationship, do they? No. Okay. Do 1 and 2 have a relationship?
Yes.
Yeah. If I ignore line D, what's 1 and 2's relationship?
Alternate exterior.
Yes. So I can say that angle 1 is congruent to angle 2 because of alternate exterior angles. And I'm okay if you abbreviate. Y'all see what I'm doing there? That's my angles, right? Right? And theorem, THM. Just make sure you don't just say alternate because I need to know if you're interior or exterior. Yeah, 1 and 2's relationship is they are alternate exterior angles, right? Now looky here, this is very similar to the last one. What can I do now? Look at my statements.
Set.
Angle 2 and 3 are congruent.
Angle 2 and angle 3. How is this different? This is not much different than the last one, is it? No. Angle 2 is congruent to angle 3 because of what property? Transit. They're both congruent to angle 1, so they must be congruent to each other, right? And do 2 and 3 have a relationship that would make those lines parallel? Yeah, they're alternate interior again. So the only thing different is this relationship right here, right? Starting out in a different position. So now I can say C is parallel to D because of the alternate interior angles. What theorem? Converse. Always got to use a converse to prove lines are parallel. Okay, so yeah, the only thing different in this proof than the last proof is this step right here is 1 and 2's relationship. Does that make sense? I could have also used 3 and 2's relationship to start with, right? Between these two. Let's see. Yes, I could have used theirs to start with and went backwards, and then that would have been that theorem. Okay, so y'all proofs might not look exactly the same from one person to the next. Now I've given you a U try right here, but it's a fill in the blank. All y'all and you don't even have to write the whole thing down if you can fill in the blank correctly and just label them 2, 3, and 4. Is that okay? Okay, so find out number 2 reason, number 3 statement, and number 4 reason. Sorry, I was trying to zoom for you. And those are just marked congruent. That's what that little mark is, in case you can't tell. See if you can fill in the blanks. And I'm okay if you don't copy the whole thing. If you just write number 2, this, number 3, this, number 4, that, I'm okay. Because that's what we're trying to do right now. I can be mean and make y'all write a whole lot later. Fill in the 3 blanks. All right, discuss them with somebody, please. All right, they didn't tell you the given and the proof, but since it filled it out in the table, they gave you angle 4 is congruent to angle 5, and you're obviously trying to prove G is parallel to H, correct? So we know our last statement has to be a converse theorem, right? All right, so angle 4 and angle is congruent to angle 5, those are given, and I've already got a mark there. Now it says angle 1 is congruent to angle 4. What's the relationship between angle 1 and angle 4? Vertical angles. So did y'all get vertical angles? If you want to abbreviate vertical angles theorem, you can do VAT, and I know what that is. Okay? Right? If you write VAT, I know that's vertical angles theorem. Okay. Just for future reference, if you get in a hurry. Okay? I know what VAT is, vertical angles theorem. All right. So now it says to use the transitive property. So for reason number 3, statement number 3, what will we say using the transitive property from our previous 2 statements? Yeah, you're showing angle 1 and angle 5 are congruent. Y'all get that? Okay, and that was using the transitive property. And now obviously I'm going to use the angle 1 and angle 5's relationship to prove that these are parallel. Now what's angle 1 and angle 5's relationship? They're corresponding. So this would be the corresponding converse, and this one is actually a postulate, wasn't it? Corresponding is the weird one. It's the postulate. If you wrote that it was a theorem, I'm not going to count off on that. Okay? So raise your hand if you got vertical, 1 is congruent to 5, and corresponding converse. Any questions? Any questions? Okay, so just to make things easier on us, I have the rest of the notes today on a handout. Okay, we're not going to do all of these, but we're going to do the majority of them together. Because the more we do together, the more examples you have for when you are doing them on your own, right? But if you notice these proofs when you get them, they're 100% blank. All the statements are not there. All the reasons are not there. We got to do it by ourselves. My Jonah says by your own self. You got to do it by your own self. So we're going to do it by our own self. Okay. Because we're smart, right? You might want your properties handout, your theorem and stuff handout. And we're still using properties such as transitive and things. All right, can y'all see this? All right, so maybe I can get all of it on the screen. All right, now just another thing to make note of before we get started. They have allotted us a certain amount of spaces for our statements and reasons. There's some proofs that we might need more space and some proofs where we might not use all the spaces given. Okay, so don't let the number of spaces on the worksheet make you think that you have to have 8 steps or that you have to have 3 steps. Does that make sense? Okay, so that's just a place to put your answers, so don't get all confused. All right, so we got this picture and all these angles that labeled, don't we? Okay, everybody with me? So what is my first statement on proof number 1? Angle 4 and angle 7 are supplementary. And what's the reason there? Given. Again, I'm okay if you abbreviate, as long as you give me a few letters and I can tell what it is. Okay, so angle 4 and 7 are supplementary. Right? I'm trying to prove that J is parallel to K. So there we go. We know we're going to have to use a converse, right? All right. So something we can do now. So 4 and 7 are supplementary, right? Also, I see something we could do. Maybe. I'm trying to prove that J is parallel. So I need to prove. So I cannot use that until I prove that. Okay. I can say 6 and 7 are supplementary, can I? Why can I say 6 and 7 are supplementary?
The alternate interior. Or consecutive interior, or is it exterior? One of those things.
Why are 6 and 7 supplementary? Exactly. So I can say that angle 6 and angle 7 are supplementary because they are a linear pair. All right. Now look at these statements. They're both, that's supposed to be 7. My pen is just, still gotta practice this thing. I don't know what it is. I keep hitting buttons or something on the side. All right, so 4 is supplementary with angle 7, and 6 is also supplementary with angle 7. What can I say about angle 4 and angle 6? They're congruent. So angle 4 is congruent with angle 6 because of what? Y'all remember? No. That's what I'm going to have to use. The lines are parallel. Not transitive. Last unit. If they're supplementary with the same angle, then they are congruent to each other because of what? Congruent supplements theorem. Y'all, we can't forget a property or a theorem because it happened in the last unit. We learned vertical angles in unit 1. We're going to use that for pretty much the whole semester. All right? That's why I tell you, know your properties. Know them. Don't know them and forget them because that means you did not know them. And by some of y'all's quizzes, you didn't even try to learn them. Know your properties. Okay, so we said if angle 4 and angle 7 are supplementary and 6 and 7 are supplementary, then 4 and 6 must be congruent to each other because of the congruent supplements theorem, right? Right? If they're supplementary with the same angle, then they are congruent to each other. Now, looking at the picture, stop it, go away, go away. Does 4 and 6 have a relationship? What is that? They're alternate interior angles, right? Right? So if alternate interior angles are congruent. See, I could not use that because nothing told me that the lines are parallel. Y'all see that? I couldn't use alternate interior angles to start with because nothing told me that the lines were parallel. Does that make sense? I've only got one pair of lines and that's what I'm trying to prove are parallel. Does that make sense? So I can't use anything about the relationships until I prove the lines are parallel. Does that make sense? Because nothing told me anything about parallel lines to start with. Okay? So now I can say since they're congruent to each other, they're alternate interior angles, but we're proving the lines are parallel. So J is parallel to K because of the alternate interior angles converse there. Okay. So you do not have these relationships until you prove the lines are parallel. Does that make sense? Or something tells you the lines are parallel. On number 2, we can use the relationships because on number 2, they tell me something is parallel. Y'all see that? That's an interesting picture, right? All right, so look at it. I got A parallel to B, so I'm going to go ahead and label that on my picture. Draw the little marks. A is parallel to B, and angle 2 and angle 3. If I don't quit popping up random stuff over here. Angle 2 and angle 3 are congruent. So those are my givens, right? A is parallel to B, and I like to put my givens, when they give me a choice like this, I like to put all my givens on the first row. Some people like to split the givens. I like to have all my givens together. All right. I'm trying to prove that angle 1 and angle 3 are congruent. So I know 2 and 3 are congruent, and I know that these lines are parallel, right? Well, if I ignore this little stick right here, isn't that a transversal?
Yeah.
Do I see a relationship in there? What has a relationship? Angle 2 and angle 1 are congruent, aren't they? Why are angle 2 and angle 1 congruent? Yeah, so I can use the relationships because that told me that A and B are parallel. Does that make sense? So since I know they are parallel, then I can use the relationship. So angle 1 is congruent to 2 because of alternate interior angles. Okay, now look at what I can do. What can I say now? Yeah, they're both congruent to angle 2, so angle 1 and angle 3 must be congruent to each other, right? Because of what property? Transitive property. Is that what I was trying to prove? Yeah. So you're done. So you know you're done with your proof when you have proven what it said to prove. If your last statement is what it said to prove. Does that make sense? That's how you know you're done with your proof. When your last statement says what it says to prove. How do I get good at these, friends? Practice. And I like these little short ones. Especially since the table's already drawn for me and so are the pictures, right? That's a bonus. Okay. Question.
Yes, sir.
They've given me 2 angles are congruent, right? 1 and 7. All right. So that's what my given is. Angle 1 is congruent to angle 7. So before I can use any other relationship, I need to say that the lines are parallel. Do y'all see that? Do I have enough information to say that those lines are parallel? Do 1 and 7 have a relationship? What's 1 and 7's relationship? Alternate exteriors, right? So I can say, since they're congruent, then I can say that line L is parallel to line M because of the alternate exterior angles converse theorem, right? I should write converse in case y'all get confused. So now that my lines are parallel, now I can use other relationships, hopefully to prove that angle 4 and angle 8 have a relationship. Do angle 4 and angle 8, now that I know these lines are parallel, do they have a relationship? What's 4 and 8's relationship? Corresponding angles. So now I can say angle 4 is congruent to angle 8 because they are corresponding angles. Do y'all see what I'm saying there? You have to have the lines parallel before you can use the relationship to show angles are congruent. Does that make sense? Angles postulate. And if you're just proving angles are congruent, you don't use a converse. You only use a converse if you're proving lines are parallel. Questions? Anybody? All right. I'm going to skip 4 and 5. Let's look at number 6. Actually, skip number 6. Y'all are geniuses. Let's do number 7. Y'all are so smart. I'm ready to turn y'all loose on some practice. Now this one has a lot of blanks in it, so it might be long, but not necessarily. Mine's not long on my paper. So I did it in shorter steps, so that's okay. So go to number 7 and go ahead and fill in your statement and reason for the given. So angle 1. My pen. So do I know that lines are parallel? Do I know that the lines are parallel yet? No, that's eventually what I'm trying to prove, right? So I honestly cannot use any of these. Can't use any of them except for maybe a converse theorem, because that's what I'm doing to show my lines are parallel. Because I only have 2 lines and 1 transversal. Does that make sense? Okay, so I need to use some other properties and theorems that I've learned previous to yesterday to help me get there. All right? So 1 and 7 are supplementary. Okay? Is angle 1 supplementary with something else? Yep, that's one thing I could do. I could do that, or don't these 2 have a relationship? That they are supplementary? Okay. Well, that one, since it's with 1, what can I say about 1 and 6? They're congruent because of why? The vertical angles. Let's do that. So sometimes you just got to look at different options and see what you can do. I like that option. Angle 1 is congruent to angle 6 because of the vertical angles theorem. Okay. So if angle 1 is congruent to angle 6, can I then say that angle 6 is congruent to angle 7? I mean, angle 6 is supplementary with angle 7 then? Because of what? Substitution. Yeah, this is probably going to be the best way for us to do it. There's other ways. Y'all see what I did there? I use vertical angles. That's not how you spell substitution. Forgive me, Lord. Substitution. All right, so 1 and 7 are complementary. 1 and 6 are vertical angles, so they're congruent. And since 1 and 6 are congruent, I can replace 6 with 7. Right? Now, do 6 and 7 have a relationship being supplementary that I could say that those lines are parallel? Not alternate. Yeah, consecutive interior angles are supplementary, and they are consecutive interior angles with each other, aren't they? So now I can say that A is parallel to B because of consecutive interior angles converse theorem. Now there are other ways that we can see that. Say we were rattling off stuff, we were finding other things that were supplementary, right? We could say 1 and 5 are supplementary. That's something else we could have done. We could have said 1 and 5 are supplementary because that's a linear pair, right? And then we would have had 1 and 5 supplementary and 1 and 7 supplementary. So that would have been the congruent supplement theorem. I could have said that 5 and 7 were congruent, and then I could have used corresponding there. Does that make sense? So there's a couple ways that you could have correctly proved this. Does that make sense? Y'all see what I just said? I could have said 1 and 5 are supplementary because they're a linear pair, and then 5 and 7 are corresponding angles. So then I could have used the corresponding angles converse to prove the lines are parallel. Well, first I skipped one. You got to use the congruent supplements to show that 5 and that 1 and 7 were complementary and 5 and 7 were complementary. So they must be congruent to each other. Does that make sense? So again, you can do these multiple ways. All right, I want y'all to help each other on our practice day. This is the end of notes for today. Have a good day. Have fun doing proofs.